All right, so let's go ahead and get started. We're going to go into our anchor chart. You've got behaviors of gases at the top. We know that there's going to be two different types of proportionality, either direct or inverse. So I'm going to make two big boxes, and then I'm going to make some columns below them just to anchor all of the information that we know about both of those. So in this box, I'm going to put directly proportional. And in this box, I'm going to put inversely proportional. So if we're thinking about this directly proportional relationships, we know this is going to be things that are parallel to one another, like raising or lowering the temperature is going to either raise or lower the volume, but they're going to be the same. So I'm going to use red throughout here to represent temperature. I'm going to have temperature increasing is going to cause volume to also be increasing. Then I'm going to leave room to make a graph because I want to be able to really quickly look and see, okay, if I have a graph like this, I know it's directly proportional. I'm going to have temperature on this axis, and I'm going to have volume on this axis. And we'll come back to this in just a second. Below the graph, I'm going to put the opposite of this. So temperature and volume are up here. If temperature decreases, I know that volume decreases. Leave a little space at the bottom. We're going to draw a little model down there. So far I've got my examples. Temperature is increasing or decreasing. Volume is increasing or decreasing, but directly proportional just means that they're going to be parallel. So at the bottom, I'm going to draw some little containers. I'm going to try to make them look similar to your virtual lab from yesterday. So I'm going to have one with a pretty large volume, the whole container, and then one with a pretty small volume, a very small portion of the container. I'm going to want to make sure that the number of molecules I have in both sides is the same. So if I have 1, 2, 3, 4, 5 on this side, I want to also have 5 in here just to keep it consistent. So I've got my large volume and my small volume. So I know that if I have a lot of space, a lot of volume, I'm going to have a higher amount of temperature. So I'm going to draw a little thermometer with a taller amount of mercury, and I'll get to your question in just a second. Doop, 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 doop. Yes, volume is going to be how much space there is in the container. If I have an increased volume, it means I have more space for it to bounce around. If I have a decreased volume, it means I have less space for it to bounce around. All right, back to this. So I'm going to have an increase in volume. I'm also going to have an increase in temperature. I'm going to have a higher amount of temperature in my little thermometer. If I have a decrease in volume, I'm going to have a decrease in the amount of temperature in my little thermometer. And of course, these are not perfect, but they're just supposed to be visual representations to make it easier to remember directly proportional versus inversely. So let's go back to this graph really briefly. I know that if I'm going to have a consistent increase between temperature and volume, that it's going to be linear, and it's going to look, without drawing it with a ruler, something like this, that it's going to be a linear increase. As one increases, the other also increases, or vice versa. It could be negative also. If one decreases, the other decreases. So we're going to jump over to inversely proportional. What questions do you have about directly proportional right now? If you think of questions, type them into that little chat box, just like Ishan did. All right, let's move forward. So with inversely proportional here, I know that as my volume increases, the amount of space available increases, that my, and I'm going to use a different color, pressure is going to do the opposite. So if I have a decrease in volume, I'm going to have an increase in pressure, because an inverse is just going to be the opposites. I'm going to leave some room for a graph here again. I'm going to get to this question, and I'll come back to this in just a second. Only with temperature and volume. Temperature and pressure is also going to be directly proportional. So you could put that. Okay, I'm going to mute this. All right. For Ariana, for this, I was just using one example for both, but you would have several for directly proportional. All right. So let's go back over here. I'm gonna drop my little marker. I'm gonna put volume across this axis. I'm gonna put pressure across this axis. As my volume increases, as I make more space for my gas to move around, I know I'm going to have a decrease in pressure because there's more room for them to move about. They're not going to be colliding with one another as frequently. All right. And then at the bottom, I'm going to draw another one of those visual depictions. So I'm going to have one with a high amount of volume, lots of space for my gas molecules to move around without colliding. And then I'm going to have one with a smaller volume, less room for my gas molecules to move around, more collisions are going to be happening. So I'm going to have 1, 2, 3, 4, 5 molecules in here. In this scenario, I know I'm going to have less collisions because there's more room to move. So I'm going to have more volume, less pressure. If I'm drawing a graph for an inversely proportional relationship, I know that it's going to look, without, using specific numbers, it's going to look this way. It's going to be exponential. So this is all of the things that should have been takeaways for you for this week. I know that some of us struggled with some of the assignments as far as completing them because the graphing was difficult using Google Docs, or that we had trouble accessing some Adobe programs depending on the device that you had. And I and your science teachers are working to solve that problem. We're going to do something different next week so that you're able to access those things without having trouble. With some of the graphing next week, I'm intending, if it's linear, it's still going to be direct, Ishan. We're going to delve more into using Desmos instead of trying to make the graphs with little shapes and stuff, but you'll get more details about that next week. So what questions do you have as far as these things go beyond any other thing? This information, what questions do you have about this right now? Okay, we're going to move forward. I have taken your grades for all 5 of the classwork assignments that you're going to have graded. Most of us have done a really, really good job of getting those things turned in, making revisions, checking with me if we have questions, and that's great. I'm gonna just mute this real quick. So I want to encourage you that you are doing a really good job, and I just need you to keep doing a good job. make sure that you're checking in with me if you have questions about how to use the software or how to complete the task. Most of us are doing a really good job of that. So I want to make you feel encouraged. Keep going, keep doing what you're doing. You are doing a good job. Beyond that,